Hey guys, welcome to 7.7. Today we're going to talk about base E and natural logarithms. So base E is an irrational number called the natural base, and it is approximately 2.71828 repeating. So if you remember like pi, that's an irrational number, it goes on forever. Same thing as E here. So when you make an exponential function using E, see how I have base E here? Or you turn it into a logarithm, or when it's negative, x on top, turn it into a logarithm. That's what the graphs look like. We're going to mostly concentrate on working with it numerically. So first things first, it says, let's rewrite these in log form. So I'm going to use my circle method, and I have e to the 9th equals x. Oh, what did I just do? Just kidding, that's not what you have. You should have log base e of 9 equals x. Sorry, I just had a weird brain fart there. Now the thing is, remember with the common log, it was so common we just quit writing the 10? Kind of the same thing here. We don't normally write log base e. Instead, the way we normally write that is this, ln over there. So instead of circling that as my answer, I'm going to say ln, or the natural log, 9 equals x. It means that. It's just that this is how we would normally write that. So again, if I was going to rewrite this one, it would be log base e of x equals 7, with a final answer of the natural log of x is 7. So if I want to go the opposite way, it's just a little confusing because it's like, oh, wait a minute, what's written there? Oh, remember it's an e. E to the 2.1438 is going to equal x. E to the x equals 18. Okay, so every property that we have learned so far is going to still work for natural logs because at the end of the day, they're still just a log. So for example, on 3a, I see that they give us a multiplier outside of the log. I can pull that up to be an exponent. So this would be the natural log of 8 to the 6th. And I can pull this 2 up, so this would be the natural log of 4 squared. And then I can remember that, oh yeah, if I have subtraction, I can morph that into one log, where the first item is being divided by the second item. And now if I plug into my calculator, figure out what 8 to the 6th is, I know that this is going to be 16. Whatever that number ends up being, divided by 16. Oh, it's like 262,144. Divided by 16 is a nice, easy, what was that, 2 something, something, something. The natural log of 16,384. Much simpler than that. I mean, yeah, it's a big number, but more simple than that. 3b is kind of fun. First of all, it has all sorts of exponents that can be rewritten on top, or multipliers that can be rewritten as exponents is maybe how I should say that. And then because all these things are being added together, that means they're actually can be rewritten as multiplied together under the same log. And I'm going to go ahead and kind of simplify here because I know that 5 squared is just 25. And 2 to the 4th, if I use my Powers Pocket Guide, I know that that is 16. I guess that's just a 5y, isn't it? And you know what? I have made a mistake. The whole point of combining these is that they are no longer addition, now it's multiplication. And so when I plugged all this into my calculator, I will get the natural log of 2,000 y. And so we can use this to help us solve equations. And you'll want to keep track of this because we're going to see what this looks like on 7-8 when we get to do some word problems with natural logs. So I have base E. You want to try and get, just like solving for any variable, try and get the variable by itself. I know E actually stands for something in this case. Just try and get it by itself still. So I'm going to be adding 12 to both sides. That's going to give me 3e to the 4x equals 27. Now that 3 is a multiplier on the e, so I'm going to divide it away. And I know that 27 divided by 3 is just a nice happy 9. So do you see how now the e is by itself on the left-hand side? I mean, I know it has the exponent, but it's not being added, subtracted, multiplied. There's nothing funky going on. What I'm going to do now to get, if you have x as an exponent and you're trying to get it down, use the circle method. So e to the 9th equals 4x. I'm sorry, what did I just did the same thing as I did earlier, didn't I? Log base e of 9 equals 4x. Oh, just kidding. That should be rewritten as the natural log of 9, right? I always write it log base e first, just so that I get my brain wrapped around what I'm doing. Now, the cool thing about this is that natural log of 9, you can plug that into your calculator. Underneath the log key, if you're using that Texas Instrument 30X, underneath the log key, there's an LN key. That's the one. Hit that LN, it automatically opens up parentheses. Then if you hit 9, you should get 2.19722, etc., etc. That's not your answer because you don't have x by itself. But if I know the next thing I need to do is divide by 4, then from the calculator screen where it still has that 2.19 blah, 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 I'm just going to go ahead and hit divide 4. So my screen says ANS, answer, divide 4. And let's see, the directions said to round to the nearest 10,000th. That would be 4 decimal places. So the answer is x equals 5, 4, 9, and the 3 stays down. 0.5493. 4b is going to solve the exact same way. I want to try a... No, I think that's where we're good. Yeah, we'll do a compounded. Do we want to do compounded? Sorry, guys. Hold on a second. I gotta remember what we're doing. Yeah, we're going to stop right there.